Have a start, please.
Hello everyone, I'm Song Han Tan. Today I'm going to introduce three-dimensional image reconstruction system of rice seedling root. First, I will have an introduction about the rice root, and then is the objective and procedure of my research. And most of the time, I will focus on the material and methods. Then I will have a simple result and conclusion. Then that is the future work. We know that the rice is a major food crop over the world, and for any plant, the root is an important organ because root can intake water and nutrition from the soil. For water and nutrients, we concern about the drought tolerance and salt tolerance. And the phenotype of the root correlated to this tolerance is important issues. But the root is an underground organ, and it must have a complicated structure. So the target of this research is about to reconstruction the three-dimensional images of the rice root, and then I can quantify some traits from the three-dimensional images. But before I reconstruct the three-dimensional images, I have to capture the two-dimensional image first. So the first step is I have to develop an image platform to take the two-dimensional images I need. And then I will use some calibration images to adjust my images. Then in the development, I use a model tree as a sample. Then I take the two-dimensional images. I put the images upside down to let it look like a root. Then I remove the background and reconstruct three-dimensional images. And then I can quantify some traits from the three-dimensional images. First, my image platform is including a camera, a servo motor, and a turntable. We can see that there is a turntable controlled by the servo motors. And the camera besides is used to capture the images. A computer was used to control the servo motor and the camera. The camera will take a picture after the servo motor rotates a various angle. This is the top view of the turntable, and I put a cylinder on the turntables. Then I can have a side view image like this. Next, I rotate the turntable for 180 degrees. Then the cylinder comes to here, and I can have another images. With these two images, I can find out the center of rotation. Then I can adjust the center of rotation to the center of images. And with the grid paper on the cylinder, we know that the length of the red line is 1 centimeter. Also, and it's 157 pixels. So I can know the conversion ratio between millimeters and pixels, and also the surface area and the volume. In the research of the rice root, we plant the rice in a transparent gel inside the glass tube. But in development, I use a model tree as a text object. The model tree was grouped on a flower pot, and the flower pot was grouped inside the glass tube, and the water was used to reduce the distortion. And the image was captured by a camera. The aperture was adjusted as small as possible to make the depth of the file better. And totally 24 images was used in one reconstruction. This is the image I take, and we can see that the model and the background has a lot of difference. So I can easily remove the background. And the image after background removal and binarization, we call it silhouette. Then I can use the silhouette to reconstruct the 3D image. The reconstruction method I use is called space carving. Space carving is used silhouette to carve the voxel cube. Voxel cube is a cube composed by a lot of voxels. You can think that as a piece of clay, and the silhouette is a knife, and I use the knife to carve the clay. And this is the top view of the voxel cube. The small bar around the voxel cube is silhouette. I choose the first silhouette and projection it on the voxel cube. Then I use the silhouette to carve the voxel cube. Then I rotate the voxel cube for various angles and choose next silhouette and projection and carve again. And then I repeat the process. Rotate, projection, and carving. And after 24 carvings, I can have a three-dimensional images like this. And with the three-dimensional image I use construction, I can quantify some trace from the images. Number of the roots and length of the roots. Network volume means the volumes of the roots. And the surface area. The network width is the largest horizontal distance between 2 points. And the network depth is the largest vertical distance between 2 points. And then this is the result. I can reconstruction 3D images. And although the image seems complete, but there are still some defects appear near the range points. And the target is to describe the roots clearly, but if we want to describe the root clearly, 6 trace is not enough. So the future, well, first I think I have to quantify more trace to describe the root clearly. First thing I want to try is the diameter and perimeter of the root. Then we know that with the curved surface of the glass tube, it will occur distortion. So I want to use some image processing method to remove the distortion. And then we know the most important issue of this system is accuracy. So I will use ground truth to determine the accuracy of this system. Thanks for listening.
Thank you very much. Any questions, comments? You mentioned about the accuracy for the further research, but you didn't check.
Yes, I haven't checked it right now. I will do it later.
You're measuring some number, length?
Yes. The number of the root is the number of this. And the length is the area length of the root.
Can you measure the model directly, then you confirm the accuracy?
Yes, I will use something that I know the size of it. I use the 3D printer to print out the thing I know, and I reconstruction the 3D images. Then I can know the trace I quantify with the real ground truth, the difference.
Anything else?
Thank you for your presentation. I wonder how long you takes to make a model with two-dimensional images. Yeah. Process time. I mean.
Process time. Okay.
Yeah.
It depends on the resolution. With this image is about 1,000 cross 600. It needs about 20 minutes. And if the resolution is higher, the time was longer.
20
minutes.
20.
Okay. Anything else? when you choose the actual route, you're using this model.
Yes.
What will be changed? The same or any
the process, if I use a real route, the process of background removal will be more difficult because the background will not be clear. It will be the gel is not really transparent. It will be some kind of white, and the root is white too. So the background removal is more difficult.
You using the 24 images for one rotation.
Yes.
It is proper number 24.
I have seen someone do 12 and 40. The numbers of the images used is depend on the complexity of the root. If the complexity of the root is higher, and then the images we need is more.
Maybe accuracy will be also changed.
Yes,
depending.
of course.
So we have more time. Anything else? At the moment, you don't have any plans to try actual route.
Yes, I have tried.
You have tried?
Yeah, I have tried, but I can remove the background color.
Oh, I see.
So,
But you pick up, not in the soil.
no, I applied it in the Phyta gel. It's a transparent gel, but I don't have the good light. If the light better, I think the image will be better.
I see. Okay. So now we are going to the next presentation. Thank you very much. Next presenter is Chao Hao